everyone, it's Justin again, and welcome back to Miaville Adventure Park. The park is opening a new track shifting roller coaster today, and they're holding a contest where anyone can enter to be the first to ride it. There are games around the park where I can earn entries into the contest. In our last lesson, I got one contest entry at the loot bag table. Now my lucky socks and I are waiting in line at the fortune wheel. It's this huge wheel made up of different colored sections, and whichever color I land on when I spin it will give me a number of contest entries. Red is 1 entry, blue is 2 entries, and green is 3 entries. But here's what makes things interesting. If I correctly predict which color the wheel will land on, then I get triple the number of contest entries. Ooh. If I knew the probability of getting each color, then I could tell which is most likely. Except there aren't any probabilities posted. So how can I figure out the probability of spinning each color on my own? Here's the fortune wheel. Pause the video and take a closer look. Which color do you think I'm most likely to get? Well, there are 5 red sections, 3 blue sections, and 2 green sections. Since there are more red sections than there are blue or green, it seems like the wheel is most likely to land on a red section. But I wonder how I can find the exact probability to know for sure. There are 10 total sections on the fortune wheel. As we know from the previous lesson on the probability scale, probability represents part of a whole. So to calculate probability, we're looking for what part of the whole is taken up by our target characteristic. In our case, out of this whole wheel, what part of it is red? Pause the video here and write a fraction, decimal, or percentage to represent what part of the whole wheel is red. There are multiple ways to approach this, but let me walk you through mine. I know that in a fraction, the numerator, or the top number, represents the part, and the denominator, or the bottom number, represents the whole, or in probability, all of the total options. This whole wheel is made up of 10 sections, meaning there are 10 options of what I can land on. So I'll fill in 10 for the whole. Out of the whole 10 sections, 5 of them are red. So red takes up 5/10, or 1/2, of the wheel. We can also imagine rearranging the wheel to put all of the red sections together. Combined, they take up 1/2 of the wheel. Since red takes up half of the wheel, I should expect that half of the time the wheel will land on red. Before I make my prediction, I should check the probability of landing on the other colors. I want to have all the information to make the best prediction. Pause the video here and determine which part of the whole wheel is blue and which part is green. Let's look at blue first. There are 3 blue sections, so the probability of spinning blue is 3/10. Last up is green. 2 of the 10 wheel sections are green, so the probability of spinning green is 2/10, or 1/5. Because of their clear part over whole structure, fractions are great for writing probabilities. But when fractions have different denominators, like these, it can be tricky to compare them. Luckily, we can convert them to another form to help. Pause the video here and convert these probabilities into both a decimal and a percentage. Let's check. 1/2 is 0.5, or 50%. 3/10 is 0.3, or 30%. And 1/5 is 0.2, or 20%. Now that we know each of their probabilities, which color can we be confident really is the most likely outcome? 1/2 or 50% is the highest of these probabilities, and that's the probability of spinning red. Okay, I know I'm most likely to spin red, so that's what I'm going to predict. I'm not to the front of the line yet, so I still need to wait for my turn, but now I'm prepared. You know, to find these probabilities, we relied a lot on the picture of the wheel, but what if we didn't have that? Would it still be possible to find the probability of the outcomes? Let's do one example problem to see what that might look like. Fidget Fanatics has a display with 16 regular toys, 6 glitter toys, and 3 scented toys. If you pick a toy from the display randomly, what is the percentage probability of getting each type of toy? We don't have a visual here to help us, but I know we can still do this. Probability is all about parts of the whole. So what do you think is the whole in this scenario? The whole is all of the possible toys that can be randomly picked. But how many possible toys are there? I'm going to make my own visual to help me with this. I know that there are 16 regular toys, so I'll represent each of those with an R for regular. So that's 16 total R's. I can keep going using 6 G's to represent glitter toys and 3 S's for the scented toys. How many total possible toys are there? We can count them up to see that there are 25 total toys. You can also get this total without a visual by just adding together 16 regular toys plus 6 glitter toys plus 3 scented toys to get a total of 25. Now that we've determined what the whole is, pause the video here to find the probability of getting each type of toy as a fraction out of 25. Check your answers against mine. 16 out of the 25 possible toys are regular, so that probability is 16 over 25. For the glitter toys, the probability is 6 over 25. And for the scented toys, it is 3 over 25. Nice! We have accurate probabilities for getting each type of toy. Are we done with this problem? Not quite. We were asked to find the percentage probability, which means we'll have to convert our fractions to percentages to finish this off. Pause the video one more time and convert your probabilities to percentages. Check your percentages against mine. 16 over 25 makes 64%. 6 over 25 makes 24%. And 3 out of 25 makes 12%. So there we have it. Our final answer is that the probability of picking a regular toy is 64%. The probability of picking a glitter toy is 24%. And the probability of picking a scented toy is 12%. Ooh, perfect timing. It's my turn at the fortune wheel. I know I'm most likely to spin red, so that is my prediction for triple points. Come on, red. Let's spin. Red, 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 red. Blue. Well, I wasn't expecting that, but I guess even though red was most likely, a probability of 1/2 does not mean that I was guaranteed to spin red. But that's okay though, at least I still get 2 entries. As we've seen today, we can find and write probability as a fraction with the total number of outcomes as the denominator and the number of outcomes that meet the criteria as the numerator. We'll keep working with probability, but for today, finish up your guided notes, and then complete levels 1 through 3 of the online practice. Until next time, keep questioning, keep calculating, and remember, just because something is most likely doesn't mean it will happen. Life can be full of surprises. See you next time! Hey, hey.